Bom dia a todos e todas. Continuando as atividades do segundo Simpósio Internacional de Tecnologias em Educação Matemática, gostaríamos de agradecer novamente a todos e todas que estão nos acompanhando pela transmissão do YouTube. Informamos também que para aqueles que queiram colaborar com o evento, estamos recebendo doações. Basta acessar o QR Code que irá aparecer no canto inferior da tela. Agradecemos as doações já recebidas e convidamos a todos que estiverem assistindo ao evento que interajam com nossas redes sociais. Poste uma selfie assistindo o segundo SITEM. Marque o @GPIMEM e as tags #segundo SITEM e #SITEM 2020. Informamos também que a editora Autêntica, apoiadora do evento, está concedendo 30% de desconto e frete gratuito nas compras acima de R$ 100 para todos os livros da coleção Tendências em Educação Matemática. Basta inserir o código promocional EduMatemática, tudo maiúsculo. Neste momento, teremos a palestra Computational Modeling in Mathematics Education, proferida pelo professor Dr. George Gadanidis. George é professor na Western University, Canadá. Sua pesquisa analisa o papel da tecnologia, especialmente da modelagem computacional na educação matemática, e também busca observar a educação matemática através de lentes artísticas. George passa vários dias do ano em salas de aula, colaborando com professores na criação de formas melhores de engajar a atenção na matemática e a imaginação dos estudantes. Para mais informações, acesse imaginethis.ca. Link disponível vai estar lá no chat. George Gadanidis is professor at Western University, Canada. His research examines the role of technology, especially computational modeling, in mathematics education. His research also looks at mathematics education through an art lens. George spends many days each year in classrooms collaborating with teachers to create better ways of engaging students' mathematical attention and imagination. See more at imaginethis.ca. Link available in chat. Informamos que a palestra foi gravada antecipadamente e será transmitida agora. Posteriormente, teremos um momento ao vivo com o palestrante. We inform you that the talk was recorded in advance and will be broadcast later. We will have a live moment with the speaker.
Hi, my name is George Gadanidis. Thank you for inviting me to your conference. It's a pleasure to be here. Today I'm going to be talking about computational modeling in mathematics education. The agenda is to consider, what do we call this thing that we do with coding and mathematics? A lot of people in where I work call it computational thinking, and we're finding that that label doesn't work very well for us, and we're switching over to computational modeling, so I will talk about that. But before I talk about those things, I think it's important to give you some examples of the work that we do, so you can situate why we're considering this. So CT, computational thinking, or computational modeling in math education. Which holds the most promise in math education? And perhaps you may suggest a different label. We'll come back to these questions. Labels matter. However, without examples, they're just words. And this is why I'm sharing with you these examples. So example number one, the way we work in classrooms is by asking teachers, what do you need help with? So grade 3 teachers I was working with in a school in Ontario, Canada, said, do you have any ideas for teaching area representations of fractions? So we designed an activity where students would walk out the door or to the door. And to get to the door, of course, you have to first get halfway there. And when you're halfway there, you have to walk half of the remaining distance and half the remaining distance, and so on. So this is one of Zeno's paradoxes. Now, if you don't think about it, you can walk to the door and pass it. But if you think of all the fractions in between, it seems like impossible. How can you do an infinite number of steps and still get to the door? So students took each of the fractions that they walked and represented them as areas. So they shaded squares like this. So there's the first one, half, the second one, half of a half, and so on. Then students were asked to take scissors and cut out the shaded parts, and then put them together to make another shape. How big would that shape be? I mean, it goes on forever. So you're constantly adding forever more and more pieces, shaded parts. Would it fit in their classroom? Would it fit in the universe? How big is it? It's easy for students to notice that all the shaded parts fit within one of the original squares, and that it's possible to hold infinity in their hand. This is important for us, that feeling of surprise. We purposely design activities so students experience the pleasure of mathematical surprise and mathematical insight. We also interview mathematicians. So in this case, it's Graham Denham from Western University. And as you can see from that image, he's considering, what if we look at just the square pieces and separate them from the ones that are not squares, and have each of those go towards the corner of the square. So you can see that together they make one square, but what fraction represents each of those? You can see that the ones that are not squares are twice as big as the squares, so you've got a ratio of 2 to 1. So that would help students to get to that answer. Interviewing mathematicians is purposeful because we want to see whether the activities we're doing would interest mathematicians. Is this mathematics interesting to a mathematician? Is this mathematics worth talking about, if you want to talk with others? We believe in the work that we've done that occasional, well-designed, aesthetic mathematics experiences that offer surprise and insight raise expectation and anticipation of what mathematics can offer. Many students in classrooms don't have an idea of what mathematics is. So we're trying to broaden the perspective, and we think that helps them pay attention to mathematics because it becomes more interesting, more complex, more human. If you want to see some of these in action, we created some videos. The URLs are, I'll share my PowerPoint with the conference, and they're welcome to share this with you as well. So, or you can pause the video. I think this is a video, and you can type in the URL. So we also do coding activities to extend these. And in this case, we're using Python. We use Python as young as grade 3. We like Python for listing numbers because if you try to do it in Scratch, the problem is you can't print on the screen with Scratch. You have to create a list, you have to populate a list, you have to empty a list. There's a lot of coding involved just to print on the screen. With Python, here we have 6 lines of code. And with those lines of code, we can do 2 different things. We can list all the fractions. You can see them getting smaller and smaller and smaller, plus their sums. And we can see that it's getting larger and larger, but it doesn't seem to be getting bigger than 1 at all. It's getting closer and closer to 1. You can also, with more complex code, you can also print the graphs on the screen. So you would have the green, which is the sum of the fractions, and the blue, which is the fractions themselves. So you can see that the fractions getting closer and closer to 0. Will they ever reach 0? Will the sums ever reach 1? So if you think about walking to the door, you always reach the door. I mean, you always walk those fractions, and you still get to the door and beyond. So you must reach the whole distance to the door. So these ones must be equal to 0 in one case and 1 in the other case. Here's a Scratch program that we use. This doesn't list numbers, but it simulates a bug walking towards a strawberry. And the code just takes 4 steps: half, quarter, 1/8, 1/16, and then stops. So now students can change that and take more steps to see if it makes a difference. They can also consider putting in different fractions. Maybe 1/2 isn't big enough. What if you use 3/4? Will that get you to the strawberry? Maybe 9/10 or 99/100. Does that make a difference? The second example I want to share with you comes from, again, from a grade 3 classroom, where a teacher said, do you have any ideas for teaching symmetry? So we designed an activity where students experience symmetry as a transformation that leaves an object looking unchanged. So this is how symmetry is defined in mathematics. However, in school, symmetry is often an attribute. For example, the letter A has a line of symmetry, the letter Z does not. So it tells us something about the letters or the shapes, but it's not an action. We don't do anything with them. So that's a little bit like, looking out the window here and saying there are 25 trees and 2 boats. Now, what I did is I labeled 25 trees and boats. But imagine if I didn't have any operations. If I couldn't operate with the numbers, I couldn't add them or multiply them. How much mathematics could I do just by labeling things? Either it has a line of symmetry or it does not. It's 5 trees instead of 4 trees. So what we do in the classroom, the teacher in front of the class has a square in her hands, and she says, close your eyes, and I'm going to transform the square. Then they open their eyes and they say, well, it doesn't look like you did anything to it. It looks the same. What could I have done to it so it looks the same? Well, they said, maybe you did nothing to it. And the teacher would say, that's possible. It's possible to do nothing. That's an acceptable transformation. Just like you can take the number 2 and you can add nothing to it, or 0, and that's acceptable. You can do that, and you still get 2 out of it. But what else could I do? And then students start discovering the different transformations, like you can rotate it, and you can flip it, and so on. We also then, we wanted to use Scratch initially, but the problem with Scratch is it does rotate nicely, but it doesn't flip, it doesn't reflect. So you can't do reflections. I mean, you can write code to do that, but then it becomes very complex. So we created our own coding environment using Blockly. And here's the first version of that program, which is getting students to rotate and reflect squares and see what happens. So you can see that that we also labeled the square with dots in the vertices, 1, 2, 3, 4. So you can see its orientation. In this case, what you're seeing is that this square is rotated 90 degrees. So starting from the upper left-hand corner, used to be 1, 2, 3, 4, and now it turned 90, it became 4, 1, 2, 3. So those permutations on the left that you see, those numbers 1, 2, 3, 4, 4, 1, 2, 3, can be seen as labels, attributes, but you can also see them as transformations. So for example, if you look at the square that's there on the screen, and I said to you, do 4, 1, 2, 3, you would then have to rotate it 90 degrees because that's an abstract instruction. It's not saying put it so that it looks 4, 1, 2, 3, but rather, no matter what it looks like now, take the 4th vertex and make it first. Take the 1st vertex and make it second, and so on. So you can see how we're getting, with very young students, a sense of abstraction just by looking at the permutations. They love the word permutation, by the way. And then we consider, well, we've only discovered 8 permutations, 4 for rotations and 4 for reflections. How many are there altogether with the numbers 1, 2, 3, 4? So students create organized lists. And they circle the permutations that are rotation symmetries, and they underline the permutations that are reflection symmetries. Now, can you tell them apart? If I showed you a rotation symmetry permutation, would you know that that's what it is and it's not a reflection? Can you tell this by looking at the order of the numbers? So that's a question to consider. So you can see new mathematics emerges when something becomes a transformation, as something that changes other things. It's an action. So when students, I was working in a grade 2-3 classroom, and one of the grade 2 students called me over and said, there's something wrong. And I said, what's wrong? He said, I did 2 reflections and I got a rotation. I said, that's interesting. Why don't you try 2 different reflections? So he tried some more, and he was always getting rotations. And I said to him, boy, it looks like you may have discovered something new. And he looked up at me and said, math is so cool. Now, it's interesting that at such a young age, you can make these discoveries. I have to do underneath of this is the essence of closed or open sets, groups or not groups. In this case, if you reflections, you might say, like to meet other transformations, whereas the rotations hang with each other. They always stick with themselves. No matter how many rotations you do to a rotation, it's always a rotation in the end. But if you flip or reflect something twice, so imagine you have this piece of paper that's a square. You flip it once, and you flip it again, it goes back to this side. And on this side live all the rotations. You can rotate all you want, you're always on this side. If you flip, you go to the other side. Flip twice, it's a rotation. Flip 3 times. So if you do an odd number of reflections, you're going to get a reflection. An even number, so you get a rotation. And students discover this as well. Now, these tools are tools to think with, as Papert said. So it's not like we create them and then we have a purpose and that's the end of it. They affect us as well. They change the mathematics that we can do. They changed how we do the mathematics, but also give us new ideas about what we can do with them. So for example, we thought, what if we just put the symmetries in this sandbox and let them go? So in this case, you can see at the bottom that we have the 4 rotation symmetries, 0, 90, 180, and 270, and they're different colors. And these are the 4 reflection symmetries. So we put these 4 rotation symmetries in here. And with the code, we ran the code, and now they're randomly moving and bumping to the sides and then bumping against each other. So you can see here that the blue and the green bumped into each other. Blue is 90, green is 180. So then now they're going to transform each other. The 90 is going to rotate the 180 90 degrees more, so it becomes 270 or yellow. And the 180 will reflect, and the 180 will reflect the 90 180 degrees more, and that will become yellow too. So if we let this go, those two that bump each other will become 270 or yellow. So the question now is, if we let this go, what would it look like in the end? Can we tell? So I was working in a grade 6 classroom, and we did this for the first time in that class. And we did all the other activities with symmetry, and then we get to this one. And I said to them, what do you think? And I said, if you have an idea, come up and whisper it in my ear. And 3 students came up. And all 3 students had a different answer, and all 3 answers were correct. One student said they're all red. One student said they're all going to be 0. And one student said they're all going to be 360. Those are all the same thing. One student said they're all red. And it makes sense, because one student said they're all going to be 0, and one's the only stable state. They're all going to be change anything. Whereas if you had all blue, when the blues bumped each other, they would change. It makes different symmetries. It would not be stable. They're all going to be 0. The only stable state is the only stable state. They're all going to change anything. Interesting. Whereas if you had all blues, were able to see that before they even tried it. The blues bumped each other. They're all. We also thought, we have these symmetries bumping into each other, but what happened to them, is something that happened in the past and we forget about it. Can we track it somehow? Can we create data that we can look at after all the bumping that happens? So what we did is, if 2 symmetries bump each other, then we record the result. So the 90 and the 180 gives us a 270, which is, and they're both going to be 270, which is yellow. So then you'll see a splatter on the screen that's all yellow. However, if 2 symmetries bump each other and the result is 2 different symmetries, one for each square, then it becomes 2 different colors in the splatter, as you can see. So the question now is, what would we expect to have all the colors distributed evenly, like the same number occurring the same amount of times, or not? So to do this activity, to design it, took a long time, because initially when teacher said symmetry, I thought, what can I do? It reminded me of group theory, abstract algebra. I looked at my abstract algebra textbook from university. It wasn't really very helpful for something that I can do with grade 3 students. So it took a long time to read about the history of abstract algebra, look at books that people have written about symmetry, and so on. The first one that was about infinity, that was easy because I had already done that when I taught calculus. So now that's the kind of work that we do in classrooms. How does this help us? How does this definition of computational thinking? Computational thinking, according to Google's course on computational thinking for educators, and similar descriptors are used by Wing. So computational thinking is about decomposition, pattern recognition, abstraction, algorithm design. So if I'm thinking of those things, how does it help me design what I just designed? I can't imagine being that helpful to me as an educator, as a researcher. So it's poorly defined, first of all, because all these things that you see here are also part of other subjects. Mathematics, abstraction is at the heart of mathematics. Algorithm design, of course, you design a way to solve problems. All these things belong to other fields as well. So what we've done when we use the label CT, we didn't focus on these descriptors. What we focused on were the affordances of the tools that we used. What did they afford us? What could we do differently or better? And we identified 5 things. You can put more on this list or less, but this list we didn't create this list from scratch. Other people have talked about this. Papert talked a lot about agency. He talked about low floor and high ceiling. So he talked, the fact that you're dynamically modeling. Others have as well. So it's not like we invented this, but rather we recognize that all these things that those people talk about are what we actually are seeing in the classroom. So access, low floor, high ceiling. You can teachers notice that, look at this student and look at that student. And we ask, what is it that we're looking at? And what they're saying is they're doing things that they don't usually do. They're performing at a very different level. They're interested. They're talking about mathematics. Agency. In one of those classrooms that I worked in a grade 3 classroom, this was the first coding activity. And we did what you see at the bottom there, which is do squares in a spiral pattern. So once we modeled that physically and did the coding as well, and then students were to try and create their own, this young student came up to me and she said, I'm going to make my own. I'm not going to copy what's on the screen. I'm going to do something new, and I'm going to call you and say, watch this. So that's agency. Abstraction. Well, if you look at that code there on the bottom right, it says define shape. In Scratch, you can define your own code blocks. So we defined a code block called shape. And that shape could be any shape. We can change the repeat to 3, change the angle to 120, and we have a triangle instead of a square. And that code that's general or abstract is also tangible, has a tangible feel, because you put it in some other code and you can do things to it. So abstraction gets to have a tangible feel, which is interesting and important. And automation, obviously, if you're going to do this by hand, it will take you a long time. You make a change, you have to do it again. Here, you make a little change, click on the code, it runs dynamically. You can see what's changing. And audience, students take things home. It's easier to share digital artifacts. And also within the classroom, students are talking to one another more. Becomes more collaborative. They're sharing. They become an audience for one another as well. Issue number 2, are coding skills the goal? I mean, are we teaching, or are these general abstract, descriptors like abstraction? Students become better at abstraction. Generally, not in mathematics, but generally. DeSessa said that, contrasted the view that most people use coding for in education as programming for programmers, rather than programming for users to tinker and create. Barba, working as a computational scientist, suggests that this takes us on a detour from the original powerful idea envisioned by Seymour Papert more than 30 years ago. She said, these tools are a source of power to do something and figure things out in a dance between the computer and our thoughts. But the inversion, starting with the computing as a formal thing to understand and then come to the application later, takes away its power. Also, there's a lack of attention to what happened in the past. It's as if computational thinking in education just happened. It's been going on for a long time, and it's been going on in mathematics education for a long time. Seymour Papad's work with Logo. He saw Logo as a coding environment and as a mathematics learning environment. He wrote that Logo is to learning mathematics what living in France is to learning French. And there you see the code in Logo. PD, pen down, FD, forward, 100, RT, right turn, 90, do it 4 times. You can put it in a block and make it repeat 4 times. I like that version of Logo. I wish Scratch had that option as well. And also, there's been research done in the past. Noss and Hoyles wrote about Logo, summarized the research, and said that Logo did not deliver all of what it promised because due to a failure to address non-technical aspects, such as the social, cultural, pedagogical context into which Logo is inserted. Those statements, the description I shared with you from Google and also from Wing, it's as if you do coding, you're going to become good at those things. Yeah. But in your classroom, teachers are teaching mathematics, they're teaching other subjects. How do they become any good at those things? Yes. So there's this belief that these generic skills are going to develop, and there's a history that shows that that's problematic, that idea. And this failure has been repeated today as others, as I just said, and others have written about. Computational modeling, on the other hand, is a way to shift the computing and education focus to what computing does. Turning our attention to turning our attention to what computing does very well, which is modeling. So if you look at the world around us, excuse me, the use of computational tools to model phenomena, processes, and relationships is becoming a prerequisite to scientific progress and economic success, as evidenced by the emergence of numerous computational modeling fields, such as computational biology, computational mathematics, computational finance, computational medicine, computational chemistry, and so on. So, what's next in the work that we're doing? Well, one project is, a playful project called Wonder, where we are putting these things together, videos, coding in, and we call it Wonder, and because that is something that humans are good at, wondering, being attracted to wonder, and we put 7 wonders in here, and we're hoping to have a second issue. So this is one project that we have. Another one is the Ontario curriculum right now, Ontario and Canada, was just changed to have coding in mathematics in grades 1 to 8. So every grade level is going to have coding in it in algebra, along with modeling. So it's a very powerful change. It has a lot of potential. It's not easy to implement these things well, but hopefully, and so we're creating as well, trying to help, like others are trying to help, by creating these resources for teachers. And we're offering them at a very low cost. $4 gets you all this for the whole year, and any updates. Also, storytelling. I really enjoy and working with others writing stories about mathematics. So there's one there on symmetry, which allows you to, as a teacher, to go through the story and pause and then do the activities, and a couple of other ones. And the project that I'm working on now is called Ideas That Travel. So the question of that is, how do you share a good idea so others can share it too? How do you structure it? How do you engage people with it so it becomes something that is worth talking about? They want to say it too. They want to talk to somebody about it. Yeah. Thank you so much for listening. There's the website where you can get information on all of these things. There's my email if you have any questions, and there's my Twitter account. Thank you so much, and I look forward to your questions and discussion and comments.
Neste momento, convidamos o professor Dr. George Gadanidis, também o professor Dr. Marcelo Borba e o professor Dr. Ricardo Scocugli. Com a palavra, professor Dr. Marcelo Borba. At this moment, we invite Professor George Gadanidis, Professor Marcelo Borba, and Professor Ricardo Scocugli. With the floor, Professor Marcelo.
George, I'm here just for a few minutes just to thank you for this wonderful lecture and very critical one about mathematics education. You packed a whole lot in 30 minutes. So thank you so much for presenting to people your work, part of the work that we share internationally, and a view of computational thinking, a critical view of it. And this is just fantastic. For those of you who are here listening to us, George and I and Ricardo collaborate for 15 years. So GPMing, our research group, has 27 years, and George has collaborated with us for more than half of this time. So it's a wonderful time it's wonderful that you took your time to come to Brazil. Was everything ready for you to come? But anyways, we are in this pandemic here and with this whole new situation. Also, for those of you who don't know, George and I collaborate together with Ricardo and some graduate students here, including Lara, who is presenting. He's behind the stage of this conference a lot. We collaborate in a CAPES Print project. It's an international venture by CAPES, one of our main funding agents, which we're struggling to keep the funding to research, and George is helping us. So, George, I'm just going to make a short translation of that into Portuguese, and then Ricardo will take the floor, okay? And I will disappear, but I had to be here in public to say hi and thank for all your support, and of course, Jeanette too. Jeanette Hoots is his wife and collaborated in the project and was in Brazil in February giving a fantastic course that, we have data, and we're going to be putting some papers on it pretty soon about that puts together George's talk today and Zolt's talk yesterday of critical making and STEM and, science, technology, engineering, arts, and mathematics. Bom dia a todos mais uma vez. Eu entrei aqui um pouco apenas para saudar o meu amigo George Gadanidis, que colabora com a gente há 15 anos, nos 27 anos do GPI, em 15 anos ele está com a gente. Então já é quase um membro do grupo e atualmente ele colabora com a gente no projeto CAPES Print. A esposa dele, a Jeanette Hughes, que é uma pessoa não de educação matemática, mas de informática educativa, também colabora com a gente nesse projeto e com vários doutorandos que estão aqui, em particular com a Lara Barbosa, que é uma das principais organizadoras aqui desse evento. Então, a gente está aqui para agradecer muito o George. A palestra ele conseguiu em 33 minutos, colocar um monte de coisa sobre pensamento computacional, uma visão crítica disso, e uma boa parte do que ele apresentou é parte da nossa colaboração que envolve alunos de doutorado. Então, muito obrigado a todos pela presença. Obrigado, George Gadanidis. Thank you, Ricardo. Now, Ricardo, the floor is with you. And thank you once more, George.
Good morning, everyone. My name is Ricardo Scocuglia. I'm a professor at São Paulo State University. First of all, I would like to thank the organizers for inviting me. So, thank you, Marcelo. Thank you, all the organizers of the symposium. Actually, it's my great honor to be trying to help in the translation of George Gadanidis' translation of this talk. I will try to summarize the lecture in English, from English to Portuguese, and afterwards we have questions. But during the questions or during this transmission, feel free to, make my English, my Portuguese better, my translation better, and feel free to ask questions along this summary as well. So, bom dia a todos e a todas, meu nome é Ricardo Scuculha, sou professor da Unesp, gostaria de agradecer as pessoas, os organizadores, em especial o professor Marcelo Borba, por esse convite para estar ajudando aqui na tradução, né, do inglês para o português. Obviamente eu não vou traduzir literalmente, eu vou fazer algumas sínteses, né, muitas vezes eu vou usar minhas próprias palavras para estar sintetizando. Sintam-se à vontade, né, para me ajudar na tradução, para melhorar a minha tradução, né, podem usar o chat, podem utilizar, e ao longo da apresentação, fazer perguntas também. Assim, por vários motivos, né, para mim, como eu disse, é uma grande honra poder estar ajudando nessa tradução. O professor Jorge Gadanidis e o professor Marcelo são meus orientadores, né, na realidade, para mim não tem essa de ex-orientador, orientador é para a vida toda, então, tá? Bom, o título da palestra, né, do professor Jorge Gadanidis, é Modelagem Computacional em Educação Matemática. Então, eu acho que uma das principais ideias, ele pontua um movimento que é feito do que é chamado pensamento computacional para o que ele está denominando modelagem computacional, né? Então, isso não é só um rótulo, na realidade, só um título, mas algo conceitual e há uma razão pedagógica e também epistemológica para ele fazer esse movimento, tá? Eu decidi estruturar essa síntese em 3 partes, tá? A primeira parte é o primeiro exemplo que ele traz para a gente, né? Segunda parte, o segundo exemplo, que é um pouco mais longo, e aí a parte final é onde ele vai conceituar, com base nos exemplos, né, a ideia de modelagem computacional, tá? Algo que eu achei interessante, né, que ele destaca na fala, com relação aos 2 exemplos que ele traz, né, o primeiro que explora a ideia de série geométrica, né, uma variação do paradoxo do Zenão, o segundo sobre simetrias, mas em ambos ele comenta o quão é importante isso, a decisão, né, quais ideias podem ser exploradas, ou ele decide explorar, isso vem dos professores, né, é uma demanda dos professores. Então, no primeiro exemplo, a demanda do professor foi, como que eu posso explorar frações e área, né? E aí ele desenvolveu, né, ele desenhou uma atividade na qual os alunos poderiam explorar a série meio, mais 1/4, mais 1/8, assim por diante, né? Isso tem uma relação com o paradoxo comum, né, dos paradoxos de Zenão, tá? Então ele acha que, assim, que é uma grande ideia matemática por vários motivos, conecta vários conteúdos, mas também explora a ideia de infinito, que é um conceito bastante complexo em matemática e outras áreas, e também oferece surpresa, isso é importante na definição das ideias a serem exploradas, traz surpresa para os estudantes, né? E ele, em um dos trabalhos, ele também ele entrevista matemáticos, né? Então, as ideias matemáticas que são interessantes e importantes para os matemáticos, é importante que elas sejam também para os alunos, né? E aí, no primeiro exemplo sobre a série, né, meio, mais 1/4, mais 1/8, ele faz inicialmente uma abordagem utilizando Python, né? E aí ele menciona um trabalho com alunos de 3º ano, tá? E ele dá um destaque para o Python em relação ao Scratch, porque alguns elementos, né, presentes no Python, eles são mais fáceis para imprimir, né? Então, se você quer uma tabela numérica ou um próprio gráfico, é mais fácil do que no Python, né? E aí ele apresentou, né, algumas frações relacionadas à série que ele estava explorando, o gráfico, e assim por diante. Depois ele apresentou o Scratch, ele também fez explorou esse conteúdo, essa série, né? No Scratch, ele colocou aquele exemplo, aquela simulação que tem um inseto chegando, buscando alcançar, né, um morango, e aí o movimento realizado pelo inseto condiz com os termos da série. Então ele anda meio, depois um quarto, um oitavo, e assim por diante. E aí ele destacou que, por exemplo, no Scratch você pode variar, né, o termo dessa série, ou os termos. Ao invés de trabalhar com meio elevado a n, você pode trabalhar, por exemplo, com 3/4 elevado a n. Tá? Eu acho que essas são as principais ideias sobre o primeiro exemplo. Tá? O segundo exemplo é sobre simetrias. Então, ele também, a demanda foi de um professor, como que eu posso trabalhar aqui simetrias. Então, no início, ele colocou um conceito geral sobre simetria que envolve o antes e o depois, né? E aí ele deu um exemplo de uma situação, ele fala para o aluno, olha esse quadrado, agora fecha os olhos. E aí ele mostra o quadrado numa posição depois do que aconteceu e pergunta o que aconteceu. Então, esse o que aconteceu é importante no conceito de transformações, né? Transformações geométricas. Ele mostra um exemplo com o Scratch. Ele fala, daria para explorar com o Scratch. Mas ele menciona que com o Scratch dá para a gente rotacionar, mas não dá para a gente fazer a reflexão, tá? O que ele chama de flip. Né? Então, ele propõe, na realidade, ele cria um ambiente de programação utilizando o Blockly, então, praticamente ele cria um aplicativo, e aí ele pode trabalhar, enfim, translação, rotação, reflexão, e assim por diante. E aí, ele adiciona a isso alguns conceitos que permitem também trabalhar permutação, né? Então, nos vértices dos quadrados são colocados números, e aí, dependendo da transformação que você fizer, principalmente rotação, você tem sequências diferentes, né? Então, você tem permutações nesse sentido, tá? E aí, trabalhando, por exemplo, com alunos de segundo e terceiro ano, ele comentou uma situação em que aconteceu o seguinte, o estudante falou assim, tem algum erro aqui, né? Eu fiz 2 reflexões e deu uma rotação. Aí ele perguntou, tenta de novo, por que você não tenta 2 reflexões? 2 reflexões diferentes, né? E aí o estudante ficou, né, ele destacou, falou, estudante, você descobriu algo novo, e o estudante, né, falou, nossa, e a frase que o estudante disse é math is cool, is so cool, né, que matemática é muito legal, né, o que remete àquele conceito que ele colocou sobre a surpresa e assim por diante. Aí ele fala diferentes possibilidades, né, de trabalhar com rotação e reflexão, e aí ele dá destaque ao seguinte, um conceito do Papert, que é tools to think with, então os recursos ou as ferramentas para se pensar com, né, e aí pensando com essas ferramentas, ele elabora um outro aplicativo, né, ou uma versão mais complexa, eu diria, tá? E nesse novo aplicativo, você tem 4 possibilidades de rotações, 4 possibilidades de reflexões, né? E aí, fica algo bem legal. Você escolhe os quadrados, eles têm cores, e eles têm uma transformação atribuída a ele. Eles começam a se movimentar aleatoriamente na grade, e quando eles se chocam, a propriedade de um transforma o outro, e vice-versa. Então, ele pega um quadrado azul, que é uma rotação de 90, um quadrado verde, que é uma rotação de 180, quando eles se chocam, ambos se tornam, né, o resultado disso é uma rotação de 270 graus, e aí ambos se tornam amarelo, né? Eles perguntam para os alunos, o que vai acontecer se isso acontecer, se isso continuar acontecendo, o que você prevê, né? E aí, com uma sala de alunos de 6º ano, ele comenta, vieram 3 estudantes com 3 diferentes respostas e as 3 estavam corretas, né? Um respondeu, o que vai acontecer é que tudo vai ficar vermelho, o outro respondeu, tudo vai ficar 0, e o terceiro respondeu, tudo vai ficar 360, tá? E aí é legal ver esse movimento, né? O aplicativo se tornou mais complexo ainda, né? Então ele, na realidade, colocou como eles poderiam se chocar, né? E quando eles se chocassem, ia deixar um registro da cor, resultado daquilo. Se fosse uma mesma cor, uma única cor, agora se cada quadrado se tornasse uma cor diferente, ele ficava uma cor combinada, né? E aí ele destaca que, então dá um registro de cores, né? E aí ele comenta que para o design, né, para programar isso, demanda muito, muito tempo, na realidade. Ele buscou em teorias, conceitos em teoria dos grupos, conceitos em álgebra abstrata, para poder estar elaborando esse aplicativo, né? Indo para a última parte agora, tá? Onde ele vai, com base nesse trabalho, explicita o movimento de pensamento computacional para modelagem computacional. Primeiro ele traz alguns conceitos, né, elementos da Jeanette Wing, que é um grande nome em pensamento computacional, né, em ciência da computação, educação, matemática também. E ela traz, por exemplo, alguns elementos são decomposição, padrões, abstrações e algoritmo, né. Isso, na realidade, na opinião dele, é um pouco, ele chama de, uma definição, entre aspas, pobre, né? Em que sentido? Isso é realmente útil no trabalho dele? Ele fala, nem tanto, né? Ele acha que existem outras, o trabalho que ele desenvolve é necessário outros tipos de definições, tá? E aí, ele vai e propõe alguns elementos, né, para o pensamento computacional que ele chama de affordances, que seriam propriedades. E ele fala de 5 propriedades: acesso, agenciamento, abstração, autonomia e audiência. Tá? Uma segunda questão sobre pensamento computacional que ele traz uma inquietação é com relação às habilidades, né, de que maneira isso é destacado. E, por último, uma terceira questão que ele problematiza o pensamento computacional é assim, isso está aí há muito tempo já, não é de hoje, e parece que, assim, as pessoas trazem como novidade, né? Então, ele fala do trabalho do Papert, né, há 30 anos ou mais atrás, do Richard Noss, da Celia Royals, né? Com isso, ele vem com base nessas inquietações, a esse conceito de modelagem computacional, que ele fala que, na realidade, é dar atenção ao que os computadores fazem bem e fazem muito bem, né? Que é modelar fenômenos ou situações em áreas diversas, na biologia, na economia, na química e assim por diante. Tá? Por fim, ele fala quais são os projetos atuais dele, a ideia do wonder, que é o maravilhar-se, então ele tem lá 7 sites, vamos dizer assim, 7 espaços, 7 propostas ou designs de atividades para esse maravilhar-se. Há uma interface bastante grande com o currículo de Ontário, né? E ele destaca como que o currículo de Ontário trouxe, ou tem trazido mais recentemente, com a ideia de pensamento computacional para o próprio documento. Um outro projeto sobre storytelling, que é contação de história. E, por fim, um projeto que é Ideas to Travel, né? Ideias para viajar, que é como que a gente pode buscar maneiras efetivas de engajar os estudantes em grandes ideias matemáticas, tá? Esse aqui foram, então, os pontos que eu decidi estar sintetizando, tá? Certamente há outras ideias muito importantes que não foram comentadas aqui, mas eu vou abrir para questões, tá? So, George, I tried to summarize the main ideas you presented. Of course, I used, in many parts, my own words, but I think was somehow helpful to students to understand some aspects. And so we have actually many questions already. So can I start with the questions?
So I've looked at the questions on YouTube.
Oh, okay.
So
yes.
I have them here so I can go through and answer them. I just want to say, first of all, thank you, Ricardo, for translating. Maybe Marcelo could translate what you said into Greek so I can understand it. So I want to say, thank you so much for inviting me to your conference. As Marcelo said, our connection with GPM and Brazil has been a long one. Marcelo and I met in 2005 at a conference on ICNI conference, and we chatted on the last day, and just a brief talk spurred so many ideas. I've been, from the beginning, really interested in the idea humans with media, and when I met Ricardo, it became humans with music. I wanted to be a rock and roll star like him, and we had a number of your students that visited here as well. So the exchange of ideas has been wonderful, and to be able to think with you and to know that there's someone else far away that cares about similar ideas has always been very inspiring. So it's a pleasure to be here, and sorry I can't be there with you. That would have been perfect. So the questions. So Carolyn Miranda Pereira Lima asked about how do we prepare teachers before we work with them in classrooms. So we do have sessions with teachers, but very often the work that I do is we do a lot of email conversation back and forth. I said we'll send it because I know what the questions are that they have. Yeah. We always start with, what can we help with? What do you need? What do you need? They tell us the topics. We create some activities. We send it to them, and then I myself go to the classroom and we do the lesson together. So, for example, a couple of years ago, I worked in 20 schools with one teacher from each school, and I spent 4 to 6 days visits in each classroom. So that's about 100 visits in 1 year in classrooms, and doing lessons, collaborative lessons with teachers. So that's how we work. And that's how I like that, because I learn a lot. As we do things in the classroom, we change plans on the fly. We talk in the classroom and we change ideas based on what children are doing. Ricardo, do you want me to pause and you can translate, or do you want me to keep going?
I think I'm going to translate, George, if you don't mind.
Okay.
Então, pessoal, inicialmente ele agradeceu, né, o convite. Ele lembrou que tem colaborado. A primeira vez que ele encontrou o Marcelo pessoalmente foi em 2005. Eles conversaram sobre seres humanos com mídias, né? Na época o Marcelo tinha acabado de lançar o livro com a Mônica, e num curto período de tempo eles falaram sobre muitas ideias, e a partir daí conseguiram os projetos, né? Depois ele me encontrou e ficou seres humanos com música, coisa e tal, né? Bom, ele olhou para algumas das questões, ele respondeu uma das questões da Caroline Miranda, que é assim, se eles fazem algum tipo de curso de formação de professores para trabalhar essas atividades, né? O que ele destacou é assim, ele tem um trabalho bastante próximo com as escolas, né? Então ele deu um exemplo que foi bastante, eu vou chamar assim, de imersivo, no sentido que ele trabalhou aí com 20 escolas e trabalhou cerca de 4, 5 dias com cada turma, né? Então, parte de uma necessidade do professor e desse contato próximo que ele tem. Então, ele comentou que no último ano ele realizou mais de 100 visitas dessa natureza, né? E isso tem caracterizado o que ele chama de colaboração, né? De lições colaborativas.
So, back to me.
Yes, George, please.
So the next question, Basit Araujo Morales, I think. Sorry if I mispronounced her name. Asked about teacher education and how can we best prepare teachers to use computational modeling or computational tools in the classroom. So we've been doing this now in our Faculty of Education for about 6 years, 5-6 years. So we introduced a computational modeling, computational thinking course in mathematics education. So we do it in conjunction with learning to teach mathematics, learn to teach with variety of media, and one of them is computational tools. So our focus is on mathematics first, and we use these things as tools. So we always start with very good mathematics. I give you one example. I was talking to a mathematics consultant, somebody who looks after a whole school district. And she said to me, I visited a lot of classrooms, math classrooms, where teachers are using coding. There is no math happening. So you can walk into a classroom with coding, it can look very good. Children are engaged, they're active, they're collaborating, they're having a lot of fun. But how do you get good mathematics to happen with it? So that's our puzzle. That's what we try to solve.
Então, ó, na realidade, gente, eu acho que a Carolina tem duas perguntas e eu que acabei me confundindo aqui nas perguntas, mas elas se complementam, né? Então, a primeira, a da anterior que eu falei que era sobre os cursos, é na realidade sobre o design das atividades. E essa segunda, agora, ele coloca assim, ó, ele tem dois destaques, assim. O primeiro é sobre a matemática, como aprender matemática, quais são as ideias matemáticas envolvidas. E depois, como utilizar as mídias ou ferramentas, como eles chamam, tá? Os recursos, né? E aí, uma das inquietações que vem dos professores e que ele nota também é assim, em muitas salas de aula, ele vê que os estudantes estão fazendo programação, né? Isso tem acontecido. Eles estão bastante engajados no desenvolvimento de atividades sobre computação. Mas o que eles questionam a matemática que está sendo ali trabalhada, explorada, é uma boa matemática? Back to you, George, please.
Okay, so thank you. Marcelo Batista asked a question about algorithms, but I didn't quite understand it. So maybe Ricardo, if you could look at that and see if you can help me with it, or if Marcelo could write a bit more. Danubia Cruz asked about computer science or computer programming, and is that useful as well on its own? Does it have to do with mathematics? So I love computer science. One of the very few things that kept me up all night, besides looking after our children, is trying to solve a computer science programming problem. So I really enjoy it. So I think computer science as a subject is beautiful, and I think it has a lot of value on its own, studying it as computer science. However, today what people are saying is if you do coding, you're going to get all these skills. They're going to transfer to other areas as well. So a lot of schools are doing coding because they're going to get 21st century skills. They're going to become better problem solvers, better thinkers, and so on. This is not true. There's a lot of research on problem solving. Lean English has a paper with one of our colleagues that shows that this is not true. It does not transfer. It's very difficult to define what problem solving is and how it works. Really, what you want is if you really want to transfer things into other subject areas, then you have to look at those subject areas. If you want to develop mathematics, your first step has to be, your goal has to be a deep conceptual understanding of mathematics. How do I develop that? And how does this tool help me, or this other tool, or this idea, or this way of working with students? So unless you start, so these skills are not transferable, they're not even easily defined how you use them within mathematics themselves. So it's very difficult. So there are so many things around us in education. People talk about a lot of things. And I think the question has to be made simpler. how do I develop deep conceptual understanding of mathematics for students? And in that case, also, how do I make it a human experience? And that's also what we talked about. So thank you for that question, Danuvia.
Nessa pergunta, eu estou tentando identificar ainda qual foi a pergunta, mas eu fui anotando aqui alguns pontos da resposta. Daqui a pouco deixa eu só organizar aqui. Bom, o que ele respondeu, na realidade, foi assim. Ele, na realidade, ele ama ciência da computação, né? Ele é cientista da computação, e às vezes, assim, ele mencionou o tipo do engajamento que os estudantes têm, assim, né? Então, ele comentou uma ideia relacionada à transferência, né, em algumas atividades de resolução de problemas, né? E ele acha que parte disso não é alcançado, vou colocar aqui com as minhas palavras agora, da maneira como é dito, tá? Para ele, a principal questão é assim, como você desenvolve grandes ideias matemáticas, né, ideias matemáticas conceituais, né? E aí a ciência da computação pode ser um meio para isso, assim, né? Mas o questionamento inicial é como você faz esse engajamento, tá? Ele pediu ajuda na tradução de alguma das questões aqui colocadas, mas eu vou voltar a palavra a ele, e se eu organizar aqui melhor, eu melhoro essa minha tradução aqui de agora, tá? Back to you, George.
Thank you. So going back to Marcelo Batista, asked more recently, we brought examples of approaches based on the demands of teachers. The work also value demands of students. Yes, so because we have to talk to teachers first. And so the way usually reform or change in education happens is somebody has a good idea, and then they try to impose it on others. That kind of reform does not work, has not worked in the past. It wastes a lot of energy, it wastes a lot of money, and in the end, all you're doing is you're making the teachers feel bad about what they do, and they're wondering why you think you're so smart yourself. You know, and so what we do is we say, tell us what you need help with, and then once they give us a topic, we add to it more complex mathematics around it. So they teach. Teachers are professionals, they have to teach what they have to teach, and we don't change that, but we add to it richer mathematics. In terms of students, it's always about the students, in the sense that the puzzle we try to solve is, can we do something so that students are able to then share with someone else, their parents, friends, a mathematical experience that will offer mathematical surprise and insight. These are human things. How do we make mathematics human for them? I can give you more examples, but I think I'll pause there. So thank you for that. Yes, it's very important to focus on students, and that is our priority. But we talked about how we get into the classrooms, which is through the teachers. Thank you.
Vamos lá, ó. Então, a pergunta do Marcelo Batista, né? Então, ele diz, você trouxe exemplos de abordagens sobre a demanda dos professores, né? O trabalho que você desenvolve é também sobre demanda dos estudantes, né? Então, o George comentou no início que, assim, muitas pessoas tentam propor reformas, né? Reformas no ensino, assim, né? Então, geralmente, isso acontece assim, a pessoa tem uma ideia interessante, que ela considera interessante, mas aí ela tenta impor essa ideia, né, e na maioria das vezes, acaba de alguma maneira constrangendo os professores, né, fala assim, o que você tem feito está errado, Você tem feito não é o suficiente, e isso faz com que os professores se sintam mal, assim, né? O que ele tem feito essa questão, né, de falar, professor, o que você precisa, né? E essa demanda vir dos professores é fundamental no trabalho dele, né? Mas ele disse que é sempre sobre os estudantes, né? É sempre sobre os estudantes. Embora haja esse... não dê para, usando minhas palavras agora, a gente não consiga separar assim, né? E aí ele comenta também, assim, a importância que ele coloca com os alunos se surpreenderem, mas não só isso, de eles compartilharem as suas ideias com os pais, né? Isso é algo que ele destacou, assim, tá?
Thank you.
For the next, yeah?
My turn?
Your turn.
Thank you. So, how much time do we have so we know, is there a time? How much more time do we have?
I don't know exactly. I have to check, but I have about 10 minutes.
All right. So I'll try to be brief. So Edwin Tamayo asked about CT and CM, computational thinking and computational modeling and the relationship. So the term computational thinking came from Papert. He's the one who first used it many, many years ago in one of his papers. And really underlying, so when Papert created Logo, he created a tool to think with, a tool to do mathematics with. He was about creating tools to think with. So just like Marcelo and a lot of the students talk about, media and thinking with media, humans with media, how do you think with it? It becomes an actor. That's what he was about. But the way computational thinking is today, Papert is forgotten. Most people that talk about computational thinking don't talk about Papert. They talk about learning to code, and that's going to make you better at some other thing. But I could say the same thing about mathematics. Learn mathematics is going to make you a problem solver. It's going to make you a good thinker. Study mathematics, you'll be better at everything else. So every subject can say that. So what are we saying that's new that way? So it's not so much about computational thinking as how people use that term today to do things in schools. So we want it to be about subject, conceptual, deep understanding of whatever it is that you're studying, computer science or mathematics or science. Focus on that. Can we do that well? And not distract with these things that are going to make you better generally. So I guess I'm repeating myself a little bit. And I'll answer one more question. Oh, no, let me leave it. Okay, go ahead, Ricardo. Over to you.
Thank you. Então, a pergunta, eu acho que foi colocada pelo Edwin Tamayo, tá? Perguntando sobre a relação entre pensamento computacional e modelagem computacional, tá? Ele retomou algumas ideias da palestra, na realidade, né? Ele falou, ele tem percebido que muitos dos trabalhos atuais, né, eles, de certo modo, não têm mencionado, não têm trazido o Papert, né, o Seymour Papert, que trabalhou com isso há muitos anos atrás, né? Então, quando o Papert desenvolveu o Logo, ele já trouxe o conceito do ferramentas para aprender com, né? Isso se tornou central e isso é bastante importante, né? O George também mencionou uma relação que tem sobre esse conceito do Papert com a ideia de seres humanos com mídias, né? E aí, ele diz que parte disso algumas das perguntas atuais, né? O que é realmente novo? Tá? O que é realmente novo e o que traz uma compreensão, uma compreensão profunda dos conceitos utilizando computadores, né? Então, é isso que ele coloca a importância, e ele está argumentando que essa modelagem que os alunos realizam, né, esses modelos são criados, é o que tem destaque no momento para ele, assim, tá? É o que tem de diferente.
Fernanda Martins da Silva asked about the project Wonder and its use. How do we use that? So that was more of I had an idea to create something, so I like creating things. So it didn't have a use initially. Well, it did have a use, but we use it now in teacher education. So all these things that we have online are used in our teacher education program for mathematics education and for mathematics encoding or computational modeling. And we also share it widely, and we use it in project tools as well. But that project came up, you notice that there are robots in there learning mathematics. And the play on that for me was, today we're developing intelligence for robots. We're trying to make robots smarter. And in this magazine, Wonder, the robots become smarter or more human by learning how to experience wonder. They want to experience surprise, wonder, to be more human. So they do mathematics to experience that. And really what it's saying is, if this is good for robots, if we're trying to make robots intelligent, why don't we just do it with students too? Make them more human. Let them experience wonder.
Vamos lá, ó, a pergunta agora da Fernanda Martins. Ela pergunta se ele pode falar um pouco mais sobre o projeto recente dele, o Wonder, né? Ele menciona, gente, que esses conteúdos estão online, eles são utilizados em cursos online de formação de professores, né? Formação de professores em educação matemática e em programação, né? E é também utilizado em escolas, né? Atividades baseadas em atividades desenvolvidas nas escolas, tá? E ele menciona algo sobre a possibilidade, né, ou certa ênfase que há em alguns trabalhos com robôs, né, que os robôs poderiam se tornar, né, a esse pressuposto, mais humanos, se essa ideia do wonder, do maravilhar-se, fosse desenvolvida, né? Então, é esse conceito do maravilhar-se utilizado para que robôs se tornem mais inteligentes, né? E aí, ele parte dessa ideia, desse conceito, para trabalhar isso com os estudantes, né? Tá? Então, esse espectro geral de maravilhar-se para robôs se tornarem mais inteligentes e mais humanos, também ser utilizado com estudantes.
Selena Abar asked, do you solve the problems for teachers, or teachers propose any ideas? So the reason I work in classrooms so much is because I learned so much by working with teachers and students. So some teachers are more actively engaged and propose ideas, and some teachers are less actively engaged. Teachers are very busy in classrooms, and we try to be helpful, to help as much as possible by creating activities and share them with them, and then try them in classroom. So what happens in classrooms is we never just do the idea the way we planned it. It always changes because the teacher has an idea of doing this, or they notice something, or because students are going in different directions. So it's never, we think with one another, you know, humans with humans. So there's students and teachers and ourselves, and a lot of the ideas that we have come out because of that interplay, that ecology of cognitive ecology, as Levy would say.
Vamos lá, é a pergunta agora da professora Celina Bar, né? É com relação à demanda dos professores, né? São eles que propõem as ideias, e eles que propõem as demandas de solução, algo voltado nessa direção, tá? Ele comentou que, assim, ele aprende muito estando em sala de aula, com os professores e com os alunos, assim, né? Alguns professores, às vezes, são mais ativos, alguns são menos ativos, mas é importante reconhecer que os professores são muito ocupados, assim, né? Ocupados, tá? O trabalho, né, docente demanda muita ocupação, assim, tá? Ele colocou que geralmente a gente planeja as coisas, e por mais que a gente planeje de maneira... As coisas acabam não acontecendo exatamente como a gente planejou, isso é comum, mas ele destacou que, assim, esse interplay, né, essa combinação, ou essa... entre os professores, ele e os alunos, né, então é algo coletivo, ele colocou seres humanos com seres humanos nessas demandas, na realidade. Então, o que, usando as minhas palavras, acho que ele destacou certa coletividade, nem só dos professores, nem só dele, nem só dos alunos, mas no interplay.
So there's one other question I noticed from Mauricio Rosa, who asked about computational modeling and Pappert's constructionism and similarities. Yes, so yeah, really, Pappert had most of the ideas that we talk about. So we keep repeating things from the past, and really what we want to do is not forget them. So the reason for computational modeling is to get closer to Pappert's ideas. So Pappert is constructionist. He talked about, creating gears to think with, or tools to think with. And some of these things are tangible things, and some of them are a turtle on the screen that you move. But all these are things to think with. So modeling does that as well, because you make the tool something to think with and make progress, to learn, to explore something in your subject area, to learn in depth, to ask new questions, and so on. So there is not only a similarity, but a lot of the ideas we talk about are really Pappert's ideas.
Vamos lá, a pergunta do professor Maurício Rosa, em direção a um paralelo entre modelagem computacional, que o George está propondo, e a ideia de construcionismo do Papert, né? Então, o George colocou que, na realidade, muitas das ideias dele estão baseadas nas ideias do Papert sobre construcionismo, né? Então, há um destaque, né, com relação à ideia do pensar com, há um destaque com relação a atividades que promovam, de certo modo, aspectos que sejam tangíveis, né, talvez o mão na massa, o hands-on, né, e então ele reconhece isso, que na realidade a modelagem computacional busca aproximar de muitas maneiras as ideias do Papert.
So I don't see any other questions. I want to say that I think GPME is something very special. Having visited Brazil back in 2005 and a number of times since, and seeing how you all work with one another, and the community that's created, is not common. I mean, certainly we have communities as well, and so on, but to have that period of time that I've seen, well, 27 years, but 15 years that I've been watching it, and the collaborations and the students between professors and seeking international connections as well, and sharing ideas with others, you build so much. So I think it's something that you should be very proud of. And sometimes when you're in it, you may not realize it, but it's very, very special. So I'm very happy to be part of, associated with you. So if you have any other questions, my email address is somewhere on those slides. If you send a question, I'll be happy to answer it. If you write it in Portuguese, I'll put it into Google Translate and try to translate it and answer you. So don't hesitate to contact me. So thank you again, Ricardo and Marcelo and the organizing team of this conference for inviting me.
Então, ó, o Jorge gostaria de destacar, né, alguns aspectos referentes à dinâmica do grupo de pesquisa em Informática, Outras Mídias e Educação Matemática, GPIM da Unesp de Rio Claro, né. Ele diz que vários aspectos, a maneira como é constituída essa comunidade é algo único, né. O grupo tem 27 anos, ele tem acompanhado, né, eles têm colaborado, estado muito próximo ao grupo há 15 anos, né, é algo que ele se sente orgulhoso, e que é algo que os membros do GPM devem se sentir orgulhosos por serem parte dele, tá? E finalmente ele agradeceu, tá? Se alguém tiver alguma outra questão, pode entrar em contato com ele, no slide que vai ser disponibilizado, tem o contato dele, tá? E eu acho que eu vou aqui agradecer pela palestra e dizer que a gente vai se encontrar mais tarde, né, na mesa redonda, que eu vou estar mediando e na qual os apresentadores serão ele, Jorge Gadanidis e o Camilo Rian. Tá? So, George, thank you very much for your presentation, for your talk, for your attention with the questions. I just mentioned that people can talk to you, can ask questions, can, talk to you through, send you a message or something if they have more questions. And we'll see you later, right, at the round table. So, but Marcelo has something to add right now.
And something I have to add, it's not red wine, which is in the back together with the books, but I would love to have some red wine with you for lunch, or, it's kind of breakfast here in Canada. So in any case, we can do it sometime later. I would like to thank you so much for your participation in our meeting, which is still gonna take place this afternoon, but also for your very kind words about GPIM, about the research group, and about myself. And I put it on the comments there that I love the way that you interpret and take the notion of humans with media with your appeals and your beautiful examples. It's quite amazing, these 12 years, even though something like the Zeno paradox stay in many different, using different clothes, but how you create new things all the time, with low floor and high ceilings, which is an expression I learned with you, and I use a lot of my talks, not necessarily giving the appropriate credit, but now I'm confessing here.
And that's another idea from Papert as well.
Yeah,
so yeah, we couldn't find it anywhere written, but a lot of people say he said that. So yeah, and I look forward to drinking some wine or beer with you, Marcelo, soon.
Então, gente, um abraço. Eu simplesmente agradeci a ele pela maneira como ele usa a noção de seres humanos com mídias e sobre o quão carinhoso ele foi comigo, com a gente e com o GPIM e a própria noção que o Ricardo já traduziu de como ele vê a interação nesse grupo de pesquisa que tem 27 anos e que ele já faz parte do grupo, está há 15 anos interagindo com a gente. Então, muito legal. Acho que agora o Guilherme vai dar os avisos para a gente fechar essa sessão e depois a gente se encontra à tarde. Com você, Guilherme Rink.
Again, we thank you, Professor George, for your speech and mediation by Professor Ricardo. We emphasize that this transmission will be recorded on the GPM channel on YouTube. Okay? Agradecemos a fala do professor Jorge e a mediação do professor Ricardo. Destacamos também que essa transmissão ficará gravada no canal do GPM no YouTube. E aproveitamos para pedir que vocês se inscrevam no nosso canal e curtam e compartilhem nossa transmissão. Não se esqueçam de visitar nosso mural científico no site oficial do evento e aproveitem para conferir as fotos do simpósio. Obrigado por participarem de mais esse momento do segundo SITEM e faremos um intervalo para o almoço, retornando às 14 horas, ao vivo em um novo link com a mesa redonda, a BNCC e as Tecnologias Digitais. O link está disponível no chat e na programação oficial do evento. Muito obrigado e até logo.